nation state type attacks, I kind of consider them as a leading indicator of what could be normal 10 or 15 years from now.
Hey everyone, and welcome to the Industrial Security Podcast. My name is Nate Nelson. I'm here with Andrew Ginter, the Vice President of Industrial Security at Waterfall Security Solutions. He's going to introduce the subject and the guest of today's show. Andrew, how are you?
I'm very well. Thank you, Nate. Our guest today is Donovan Tyndall. He is a Senior Cybersecurity Strategist at Honeywell Connected Enterprise. And he's going to be talking to us about engineering security. He's going to be talking about how to invest, when to invest, and what the trade-offs are.
Okay. Then without further ado, here's you and Donovan.
Hello, Donovan, and thank you for joining us. Before we start, can you start with a bit of your background? Can you tell us a bit about yourself and about what you do at Honeywell?
Thank you, Andrew. I'm today a cybersecurity strategist within our Honeywell Connected Enterprise cybersecurity team. So what I do is I'm helping promote cybersecurity as a group, but then I'm also leading many of our internal initiatives and strategies. I've been customer facing as a consultant for over 17 years, focused really on our segment of industrial control systems, cybersecurity, different sectors, industries, and even different control systems, not just Honeywell. Involved in ISA 99 and 62443 as a contributor, trainer, past working group lead, vice chair and part of the ICS GWG, and also part of the Public Safety Canada advisory team. And so Honeywell is known as offering solutions to buildings. We make control products and others, but I'm not on the side of the business that develops those or installs these. I'm in the side that's actually on the consulting services, managed services, integration, and our own products. So that kind of gives us a bit of independence, or what many would call being vendor agnostic in the solutions that we do.
Andrew, Honeywell's a pretty big company. Can you tell me about them?
Sure. Honeywell's a conglomerate. They're active in a lot of spaces. I think their biggest is they do a bunch of aerospace stuff. They do a bunch of building automation stuff. I'm familiar with the branch of the company that does industrial control systems. They're one of the major players in the industrial control system space. And Donovan, mentioned it quickly, but he is with a services branch of Honeywell. So, his job is solving customer problems with Honeywell equipment or, with other equipment. And I'm going to ask him a question in a second about total cost of ownership. This has to do with, when you invest, how much you invest. Total cost of ownership is the lifetime cost of something that you buy, like a furnace or, an industrial control system or a security system. And it includes, an understanding that, money that you might spend on the solution 30 years from now, in a sense, is less valuable than money you spend now. All that's worked into total cost of ownership. So if you haven't heard that term, that's what's coming. So our topic today is cybersecurity engineering and total cost of ownership. What is that, please? Can you define the problem for us?
Yeah. So what I'm trying to do is challenge people's thinking and get them to think about cybersecurity total cost of ownership in a different way, right? So it's natural that we'll think about technology across the lifespan, but we don't often do the same with cybersecurity. What we draw to when we're making a cybersecurity decision is things like we immediately think of direct losses, right? Damage, or injury, release of a chemical, non-compliance, downtime, et cetera. And those are the things that that help drive our decision making on should we invest or should we not. But when you think longer term, you also have other types of losses, unplanned labor, inefficiencies, responding to an incident, the recovery, the reporting. So this is part of that total cost of cybersecurity. And if you are investing in a technology like a new modern control system, digital transformation, mobile devices, if that solution is not doing what it's supposed to, right? Like you just invested in new historians and advanced applications and optimization to get more out of the control system, better product. But if you can't do that because of a cyber incident, that's unrealized ROI. So these are those other direct, indirect losses. So we need to think about cybersecurity costs across the entire life cycle of the system, or its entire operating useful life, not just cybersecurity today to put in a single technology. So you need to ask these questions. What is the lifetime of this technology, of this control system, of this controller? What is the strategy across that life? And would that change your strategy? And I'll give you a story. A smart meter and a utility company was deploying smart meters in 2006, right? So you're moving from, a meter that you'd have to have people walk up to and read out the numbers on a dial. So instead, they're now moving to something smart that's connected back into that. So there was a major return expected from this. But what's happened is that since 2006, millions have been deployed. They're publicly accessible, and there's knowledge on how to tamper them, and they're easily accessible. So now they've still got many years left in their useful life, but there's so many known vulnerabilities, right? And now there's rework and all of these things. And so what I'm trying to do is get you to think about what could change in the future, okay? And often when we're investing in technology, when we're investing in cybersecurity, we decouple it from the technology. And I'm trying to say, no, we shouldn't separate them. When you're investing in the technology, think about cyber as how it's going to protect that investment.
In a sense, is this not motherhood and apple pie? Everyone wants to plan for the future. Everyone, are people not doing this already?
Philosophically, yes. Everybody wants to deploy a secure system, right? But what's actually happening in, us as a provider, or an advisor as a consultant, or as an advisor helping a customer buy their next cybersecurity technology, what happens is you'll see this concept of like the specification, or what we call a minimum compliance spec. And then when you look at these, it might be an asset owner saying, I want to buy this. I want this controller, this instrument, this control system, this virtual infrastructure. And then within there, they're very strict or specific, either the integrator or the consultant or the EPC, about exactly what they want, right? So what happens is there's limited opportunity to change the conversation to include cybersecurity. And a lot of these minimum compliance specs that come out for a turbine or a motor control is they're really focused on just, I need a new turbine, I need a new motor controller, I need a new PLC, and cybersecurity is not part of that. And so these minimum compliance specs are part of the problem, where unless they include cybersecurity, you're not going to get it, right? It's highly competitive. Everybody's going to be trying to win on price. Another is on a longer term project. There's a friend of mine told me, they experienced this thing called value engineering, where on a long run automation project, maybe building out a new unit, a new train, a new line in a facility, or a major upgrade, is it might be 3, 5, 7 years from the start to the end. And at certain checkpoints, they look at the costs, and what may happen is that cybersecurity may get deferred or pulled out. So this intent to think about cybersecurity up front and include it, what happens is we have these other things like minimum compliance specs and value engineering that, unless you're really good at justifying it or you include it well at the front, it disappears by the time that automation system goes live.
So let me just reinforce a bit what Donovan's saying here from my own experience. Yeah, sometimes the process of acquiring stuff, everything from turbines to pipes for water distribution systems, the process is very price intensive. In a lot of jurisdictions, certainly in North America, I don't know about the world, in a lot of jurisdictions in North America, public utilities are required by law to accept the lowest price proposal that meets all of the requirements. So they go to an engineering firm, they pay the engineering firm to specify the requirements for whatever, laying a new water main or automating a water distribution system or automating a natural gas pipeline. They design the requirements and then they put it out to bid, and they're required by law to accept the lowest bid. I mean, I was talking to a gentleman who switched from engineering to cybersecurity, and it was because he said he couldn't stand the business climate. He said, the last proposal that he bid as an engineer to buy all of the automation, all of the hardware, all of the software, do all the work. I live in Alberta. In Alberta, there's a goods and services tax. It's a sales tax, 5%. It's 5%. He said he lost the bid because his competitor miscalculated the GST and came in under, the gentleman I'm talking to, under his bid, and he lost money on the deal because he miscalculated 5% of the cost. And now he had to pay out of his own pocket to buy this stuff that he signed on the contract to do. So the price pressure and the pressure to do the very minimum that the requirements specify is enormous.
I'm just curious, is the law that way to avoid corruption, to avoid, give politicians giving deals to their buddies, or is it something else?
That is my understanding, that's why the law is, but there are unintended consequences. One of them is that, even if you see a proposal that seems clearly superior and costs 2% more, you have to throw it out. You're required by law to throw it out. So yeah, it does address one problem, but it creates others. Do you have a concrete example you can give us of how this plays out? What are the decisions and the trade-offs?
Yes. So I'll give you an example. It was a modern distributed control system. So they were, in a particular industry, and they had some legacy technology, and it was time to modernize the DCS. And the project began 5 years ago with a minimum compliance spec. It was led by an EPC and an engineering firm who had the skills and to orchestrate and manage the project, which is great. And then it went out for competitive bid to a number of providers, and everybody focused on the providing to the spec. But when the system was finally commissioned, what happened, it was handed off to operations, and then it's now the asset owner owns it, and it has to undergo a cybersecurity audit. And the problem was there was lots of critical findings, and we wonder, how did we get here? And it begins with the spec from the beginning, and then looking at, I spoke with them and asked, well, what happened? And they said, we had great intention, but there was a point where parts of cybersecurity were value engineered out. We just couldn't keep it in there. And what they're left with today is that, one, they have an increased risk, right? Because they don't have these added safeguards, and they're not able to protect against some of today's threats. So now they're having to address these findings. So some of the endpoint hardening, application whitelisting, vulnerability scanning, or really aggressive red teaming, these are now more difficult because the system is now in production. So what would that, if we were to reflect, what if we could do the whitelisting and the hardening and the attack surface reduction and the red teaming and all of the really aggressive testing before it went live, right? So there would be, the cost now is many times more than it would have been if we could do that up front. right? And what people think about is like, oh, the added capital cost. And yes, there is an impact on the capital cost. You'd also be considered a bit unorthodox because what you may be, specifying these years ago might be considered, this isn't normal. This is a bit of the head of the curve. But if you had the chance to do it again and look at it, you probably would have included those, right? And we get so often newer systems that are deployed based on a baseline of the past, firewalls, antivirus, etc., but they're not really stepping ahead and putting some of the more advanced safeguards with these newer systems. And they're kind of missing this opportunity to do it as early as possible.
This kind of makes sense. You're saying, we have to look forward a bit. We're saying that rework after a security audit is going to be more expensive than, doing it properly up front. But, this trade-off between, short-term capital cash flow, concerns versus long-term total cost of ownership, I would imagine that this is something that engineers deal with every day, not just in the cyber realm, but, in the physical realm in terms of, what kind of physical equipment they're going to buy and, what's its expected lifetime and how often or how soon does it have to be serviced or does it have to be replaced? A business often does not have the cash to do it right, whatever it is. Is cybersecurity in some sense different here from I don't know, a water system where you have to make a trade-off decision typically every time the water main blows out? Am I going to rip the whole thing up and replace it, or am I going to wait for the next blowout? It seems to me it's a kind of decision making that's made routinely, is it not?
I do agree. There are these cash flow decisions they're making, right? It's like buy versus lease, buy now or defer till later. In today's conversation, the part I'm trying to draw attention to is that the cybersecurity can cost more on a production system. And let's just zero in on where the real challenge exists, is that we, as professionals or practitioners or engineers, when we're trying to apply cybersecurity to a lot of systems, there's constraints that stand in our way that make it more difficult. We have to wait for an outage. We have to wait for a turnaround, or we simply can't do all of the testing or experimentation on a live system, right? And so I call that kind of like a cost multiplying constraint, right? So it's kind of like as soon as you move into a production state, you now have the criticality and safety and reliability of that system that's opposing you from being able to apply all the controls and safeguards that you want to put in. And so that's what I want to draw attention to. Now, there are cases where you don't have to invest in everything up front. Let's use application whitelisting for depending on the system, there's a case where perhaps you choose to apply it into the system up front, because then you are able to better manage the software and what's installed, etc. But it's also, what would be the challenge or added effort to do it later if we chose not to do it now? And those are the questions you ask. You say, would it be significantly harder or only a little bit harder? And then that helps you decide, could we defer this because later it's going to be harder, right? But what we don't want to do is be in the case of, we're in it presently, lower safeguards, we're at an increased risk of attack. And if something were to happen, we're reacting, right? We're either we can't detect, we can't protect, and we are, it just all of the incident response, right? So there's value in having a stronger system because of the resilience it gives you and to be able to reduce the impact of something happening, right? It's almost like hedging your bets, right? When you're picking some of this too, right? You're thinking about in the front end, let's over-engineer security a little bit, or to a degree, or at least until the next major change, upgrade, budget cycle, turnaround, migration, whatever it is, and kind of say, okay, we have to commit to something, and we're going to run with it for the next 3 to 4 years. What should that be? And then reevaluate and say, what could we do more?
All this, in a sense, makes sense in principle. You're saying, do more upfront because it's going to cost more later on. But in a sense, that's easy to say. Can you take us to the next level of detail? How do we do that?
I begin by asking a couple of questions, right? Like, what's the expected useful life of the system? What are the losses, both short-term and long-term and indirect? So I'm thinking, if we were to respond to an incident, what would be the labor costs in order to do that? Could we, if we implement better monitoring or hardening, could we reduce that chance? If we have, better controls, what are the other long-term losses we can avoid? If it were to happen, what are our gaps today? For example, can we detect? Would we be a victim of, somebody's within the environment for a number of months before we could detect them? Do we have the systems in place to detect and contain and do our incident response? And then you step back and say, what are the threats of today, and potentially a little bit hedging into the future to say, ransomware is becoming more and more common. Are we ready today? And if not, what could we do better? Or looking at, more edge threats of like specific targeting of our organization. Let's say somebody got into our Active Directory. What could we do better to make that harder to compromise or at least contain an attack, right, with privilege controls? And so you pull that together into kind of like a roadmap and a series of projects. And I think that's where this really comes out. And the projects will do things like, invest in some technologies, some procedural controls, but then also in processes. And I put a lot of attention on how organizations buy and how much cybersecurity is in the initial spec and what they ask for. I also put a lot into the engineering or project engineering and change management, because if systems are being deployed today and they don't appear to have all the security controls they should, I put the attention on change management, work order systems, work permits, project engineering as opportunities to include more cybersecurity review and expertise and in that process. And one of those approaches is like INL CCE, consequence-driven cyber-informed engineering. And really, it's an example of how we can better embed cyber engineering into our control systems, and have it part of the new systems before they go into production. Now, mindful that many of these projects are long run, and it may require in middle of a 5-year project, maybe after 2 years, to review, what we thought was acceptable at the start of the project. Is it still good today? We haven't deployed it into production, so we still have this opportunity to do a better job, right? Because even 5 years ago, ransomware was not the challenge it is today. So adding cyber safeguards today may sound unorthodox against the norm, but it's with the long-term horizon and the rework and the reaction, or we don't want to be reactive when an event occurs. That we evaluate that in our investment.
Waterfall Security Solutions is the OT security company, and we are a long-standing partner of OSI Soft. Process historians generally, and the OSI Soft Pi server in particular, are almost always at the heart of IT-OT integration and industrial security programs. Waterfall's new ebook is Cybersecurity for Pi Servers. The new book looks at the limitations of classic network security designs that use firewalls and DMZs with Pi servers. The book compares these classic DMZ approaches to modern security designs that use unidirectional security gateways. To understand how Pi servers interact with IT/OT security, and to see how to improve industrial security with unidirectional gateways, please download our new ebook. You can find the ebook at the Waterfall Security website in the White Papers area under the Resources menu.
Andrew, why are we talking about this? Is it not that everybody thinks about, short-term gain versus long-term pain?
To Donovan's example, the answer is no. Not everyone does this. You might ask why. Donovan he's talking about what's happening. He's talking about what we should do to fix it. He really hasn't talked about the why. Let me speculate a little bit about the why. You remember we had Terry Inglesby on a couple of episodes ago talking about measuring security. Well, the kinds of stuff that engineers tend to get right really reliably is the stuff they can measure. They can measure safety. They can measure the required load on the bridge. They've got numerical ways of calculating what the bridge will carry. They've got ways of calculating, failure rates for different components, combining those individual failure rates into a failure rate for the a composite artifact. They can do the same thing for reliability. They know how long things last. They know the average lifetime to maintenance. They've got numbers they can apply to the problem of how reliable is something, how safe is something. They don't have that for security. For most people, now, Terry's talking about some techniques and technologies he had for measuring security. Most people, they kind of go by the seat of their pants. They use best practices. It's a very qualitative approach to measuring how secure does something have to be. And, as a result, it's something that it because it's soft in a sense. It's not hard numbers. It's soft. It can get swept away in the initial hurry to push stuff out to meet costs. But then it comes back later to bite you. So to me, this is some of the why that we have this problem. The thing is that the threat environment keeps getting worse. I mean, a decade ago, ransomware was not the scourge that it is now. Targeted attacks were stealing information. They were not planting ransomware. Today, targeted ransomware is a thing. These bad guys are using the attack techniques that a decade ago only nation states used. They're using targeted techniques. This feels almost like it's a little bit alien to the engineering discipline. It's a little like building a bridge that has a 20-year lifespan, but not knowing what load the bridge is going to have to carry 20 years from now or even 10 years from now. And it gets stranger than that, because as time goes by, the threat environment gets worse. And, it's hard to anticipate how much worse it's going to get. But the tools that you have available become more powerful and cheaper to deploy, easier to use. So both of these evolutions are going on. Does this really fit with the engineering discipline?
I think it definitely needs to be within the engineering discipline, because then you are you need to integrate it with not only the control system but the safety and how a cyber failure mode can affect that, right? Beyond the PNID and the planning and the safety controls that are inherent into the system. But with the selection of cybersecurity, because it is a technology and it's rapidly changing, you're right. There's going to be potentially new technologies that are going to be cheaper and easier to deploy later. But and there's not going to be. Let's accept the fact that we're not going to make the perfect choices all the time for a 20-year lifespan. Let's just try to do, at least address today's threats and know that the system isn't going to change for a number of years, and be ahead of a couple of leading ones like nation state type attacks. I kind of consider them as a leading indicator of what could be normal 10 or 15 years from now, right? Not that we have to employ all of the controls to fix them today, but we can start working towards them. So, if we think about, we at least want to plan beyond the horizon of the engineering processes that bring a control system into life, or an upgrade, and also the budget cycles, because most organizations, they can't turn quickly. Budgeting is typically a year in advance, and engineering takes months. Now, exceptions can occur, but it's usually at the sacrifice of something else, right? Like you're pulling budgets from somewhere else, or you put another engineering project on hold. But if you wait for the threat to arrive, you are reactive, right? Which leaves your system is not as it's not as hardened as it could be. Then you're forced to either do that after the fact, which is a terrible situation because now it's under pressure, or it's been compromised and now you have to clean it up and restore that trust. We want to be in we don't want to be in the spot of, we wish we had whitelisting. We wish we had hardening, to reduce the attack surface. We wish we had red teamed the system. I think we need to avoid that. We want to do that ahead of time. By planning ahead, we're fundamentally proactive, and then we can reduce the number of these reactive situations. And I'm going to give you one story that's kind of on the more extreme end, and this was a ancillary system that went into the nuclear industry. It is NRC regulated, and it has very strict and stringent documentation, validation, and verification. So once the system is validated, you don't really want to, you can't really touch it without having to go through all the validation and verification again. So what this is a real project and a real organization, is back in 2013, they did the design. In 2014, they did the acceptance testing, and that's almost, now we're 7 years later. But what security controls they selected, they considered the longer term horizon of how long that system would be in production. So they employed controls in that system in 2014 that are still ahead of the norm today, right? So the level of hardening and red teaming and network anomaly detection tools, like they weren't existed yet, but they had, they've set up for network taps and whitelisting and all of this other hardening and testing. They did as much as they can to extend the useful life. And even today, on a private sector, non-nuclear, if they were to do what they did 7 years ago, you'd still be ahead of the curve. And that's a bit of the thinking here. You don't have to go as far as, say, the nuclear industry, but you're considering, when am I going to be able to make a change to this? And hedging your bets, because now they're still in a good situation where it's still going to be resilient against some of today's more advanced attacks.
So there's a couple of things in Donovan's answer there I wanted to touch on. He gave, in a sense, an extreme example of a nuclear generator who, put systems in place that just cost enormously to replace. So they have to look far into the future. But he's given other examples of, refit opportunities coming up. I think mere mortals don't need to look a decade or 15 years into the future. Mere mortals need to look, I think, really only until their next scheduled downtime. I mean, most physical plants cannot be run continuously forever. You eventually have to take them down for inspection and, figure out what's worn out and replace it, and, what is old and, you want to upgrade. So these scheduled downtimes, yes, they're very expensive. Yes, you push them off for years if you can. But when they occur, they're opportunities for upgrades. So I think, mere mortals don't need to look 15 years into the future in terms of trying to anticipate the threat environment. They need to look to the next refit opportunity and make sure that cybersecurity is on the agenda there, so that you don't have to plan for 15 years into the future. What are the attacks, the attack environment going to look like? All you have to do is put some security in place today that's going to hold us until 3, 4, 5 years from now for the next scheduled downtime, and then use the opportunity to upgrade security for another 3 to 5 years and take advantage of new security technologies and products and simplifications that might be available 3 to 5 years from now that aren't currently available. So, that's what struck me as, the problem is a little bit simpler for mere mortals. You don't have to quite look that far into the future. I get your nuclear example. The nukes are very concerned about safety. And me personally, I'm a proponent of nuclear. I think the world needs more nuclear. It's we have a climate emergency we have to deal with, but not every site is a nuclear site with that much, in a sense, that much mandate for foresight. You work at Honeywell. I imagine that this kind of advice is something that you give to customers and you give to engineering teams fairly regularly. How is this approach received by the average team, by the average industrial site?
That's a good question. Yeah. So I'm definitely a big advocate and constantly helping people justify why they need to invest in cybersecurity at all and now and all of those things. And usually where I recommend they begin is really with very simple things. So a lot of organizations say, oh, yeah, we already do that. And I'll pull a quote. This is from the 2020 Honeywell report on the state of industrial cybersecurity. When they actually asked companies how many actually do cybersecurity engineering with their control system to make it secure by design, it was only 40%. So that's really where I begin, is we've still got a lot that still need to do this. And if you say, they'll say, oh, we did include, or we tried to include cybersecurity, but if you're, the engineering process, doesn't have specific cybersecurity tasks and deliverables across that 5-year life, the 2, 3, 4-year lifespan, or project methodology to bring it, then you're not really doing it as best you could, right? Bring in things like CCE, bring in things like simple cybersecurity baselines and checklists. And where I see is when I'm trying to bring this forward, where I see resistance is in sales teams or project teams that feel cybersecurity is really just going to slow down what they want to do, right? They're like, oh no, we just want to get this control system upgraded. Like it's at end of life and we got this reliability and like it's, we need to get this, it's upgraded. And they feel that cybersecurity can be bolted on later. And in some ways it can, or they'll say, leave us alone. Let us deploy our new system. Let us get it in production. And then you can come back and do all your cybersecurity thing to it. And that's really what happens in a lot of cases is you really need to bake cybersecurity into the design of the system as you're building it. Like a good example is if you go from individual physical servers to a virtual infrastructure. And if you configure your virtual infrastructure exactly the same or the same approaches and that you would for physical, then you'd overlook virtual networking, hypervisor. These are, with these new technologies, there's new exposure, new attack scenarios that you need to deal with before it goes into production, right? So you don't want to be like the smart meter where you've deployed it and you've not thought about cybersecurity and you have this new virtual infrastructure. You're like, wait a minute, it's vulnerable. There's this, and this, and now it's in production, and now I can't. That's what we're trying to avoid here. So once we get over that hurdle that it's valued, then the way we do this is cybersecurity is like an advisor or a partner, and with a common goal of just protecting whatever the investment is, right? Mobile devices, virtualized systems, control systems, whatever. That's the point we're trying to get to.
So, Andrew, by now, our listeners will probably be familiar with CCE. Back in the day, we had Andrew Bachman on. Just recently, we had Sarah Freeman. But what is this about virtual?
Yeah, so virtual machines have been something that's sort of been used fairly routinely in the IT space for at least a decade, maybe pushing 15 years. When you talk about cloud systems, a lot of the systems in the cloud are virtual. What does that mean? Well, there's still physical computers, but these physical computers aren't running sort of one operating system, one set of applications. They're running virtual machines. They're running other virtual computers. They're pretending to be, 6 or 8 or a dozen other computers, maybe running different operating systems or different versions of operating systems. And this is something that's been, sort of a thing in the IT space forever. It is a little bit alien to industrial control systems because the control system space legitimately lags the IT space by about 10 years. The control system folks, the engineers, they're focused on safety, they're focused on reliability. They basically want to let the IT world shake the bugs out of stuff for a decade before they start using it. But this virtual machine concept is something that we are seeing being used reasonably routinely in the industrial world the last 2 or 3 years. And to Donovan's point, people really, a lot of engineers have, struggled to internalize and use security issues in their routine decision making. They really haven't figured out what are the security nasties associated with virtual machines. So, let me just give you one example. If you're running Windows, you're probably running antivirus, or even a whitelisting, or some people call it application control, where you basically only let certain executables run. You just block everything else. So this is fairly routine. People might even do this on Linux machines. You can get antivirus for Linux, but a lot of the high-end virtual machine sort of engines run their own operating systems. Can you get antivirus for the VMware hypervisor, the operating system that lets you run other operating systems? And people don't realize that if you find a vulnerability, if you exploit a vulnerability, if you're the bad guys are into the virtual machine, if they can break out of the virtual machine into the containing operating system called the host machine or the hypervisor, now they can tamper with every other virtual machine that's running on that physical massive computer. And they're often outside of the scope of sort of the security mechanisms that are built into Windows and Linux, because now you're dealing with this alien hypervisor thing. Once you're into the hypervisor, all bets are off, and you can bypass lots of layers of security. And people just, they're not taking some of this stuff into account when they're deploying the new technology. They want to get the efficiencies that virtualization gives us now that, we've got all the bugs worked out in the IT space. But, not only do people struggle to apply standard security concepts, they're not even looking at what are the new vulnerabilities associated with the new technology, in this example, virtualization. Before we let you go, can you sum up? Is there a thought you'd like to leave with our listeners here?
Yeah, I think the key mess, we've covered a lot of topics, but the key kind of takeaway and the thought change I want to leave is that think about longer term. Think 5 years, 10 years out, and what is it going to take to manage cybersecurity of the system, right? What is the expected life of that? And what is it going to look like? Look beyond just today's cost of implementing, adding on a technology or whitelisting, and consider that it's going to that investment is going to make it more resilient to attack, so then you can reduce your losses later. You're protecting that investment. You're going to increase the chances that all the benefits of that new control system or advanced application is going to do, be able to do what it's supposed to. As well, if something were to happen, you can react and respond and reduce those impacts. So think longer term when selecting safeguards, and use that longer term horizon and the challenges of trying to add this later to a live system. When you get faced with questions of, well, can't we just defer this and just add it on later? Use it to help defend and say, well, vulnerability scanning is not something you can do well or as efficiently on a production system. And red teaming, these are things that need to be done before it goes live. So those are, just think in those kinds of ways and use it to help justify why cybersecurity, why now, and the value to the organization. Now, if you'd like to know more about what we do at Honeywell, we've been dealing with industrial control system cybersecurity over 20 years. What's not commonly known is that people assume that unless you have our Honeywell control system, building system, or a Honeywell ecosystem, that we can't add value. And that's what I'm trying to, that's not true. We are consulting services and managed services and, vendor agnostic to be able to provide the assessments and the integration of these cybersecurity controls that you would add on to your control system, not only like a Honeywell system, but, everything like patch management and firewalls and Active Directory and the whole system together as a whole for both Honeywell and non-Honeywell sites. You can visit us at bcybersecure.com to learn more about our control system cybersecurity consulting services, managed security services, our SMX USB protection solution, and then also our Honeywell Forge cybersecurity suite for OT security management and industrial grade remote access. So, I encourage you to check it out and see, how we can help out your organization.
That was Donovan Tyndall. Andrew, do you have anything to take us out with?
Yes, I have two takeaways from Donovan. I think that Donovan has pointed out very clearly that even if we cannot measure the strength of our security posture, or we can't specify that posture in our engineering requirements, we can still look forward and predict many of our costs. If we can see that skipping a lot of security prep work means that we're almost certain to fail our first corporate security audit, well, that failure, that's going to cost us a lot of rework. It's going to cost us rework on a live system. And that's going to be very difficult and very expensive. So even if security is qualitative and nebulous, the costs are not. Those anticipated costs, they're really much more predictable. And a second point that I took is, look, the threat environment is getting worse, and if we don't anticipate that worsening, if we don't harden our systems against what's going to come at us, in addition to what has come at us in the past, if we don't harden those systems, we may pass our first security audit, but we may not pass the second or third or fourth one down the road when the threat environment has evolved. Then again, we're going to have all those nasty security costs where, we're going to incur all that security rework again on a live running system, which is very difficult and very expensive. So, look forward both threat-wise and cost-wise is the message that I heard.
All right. Thanks to Donovan Tyndall for joining us on the podcast, and thank you, Andrew, for joining me for commentary.
Always a pleasure. Thank you, Nate. We'll catch you next time.
This has been the Industrial Security Podcast from Waterfall. Thanks to everyone out there listening.